So this is all 7-8 was using the determinants to find area, collinear, and then solve the system. So this is the area one. So we rewrite, and the order of the points don't matter as long as it stays with its partner. And then we fill the third column with ones. We duplicate the first two carefully, making sure if there's a negative, we rewrite it with a negative. And then top, left, bottom, right is first. So this would be -3 times -3 times 1 plus 2 times 1 times -4 plus 1 times 2 times -4. Now, I know you guys are smart and sometimes also lazy, and so you don't write that stuff out and you try to do it in your head, and that is where you will mess it up. So I'm telling you right now, take that extra 5 seconds and write it out. So you get 9 minus 8, or 1 minus 8, which is -7. Then we go back the other way. So -4, -3, 1, plus -4, 1, -3, plus 1, 2, 2. So positive 12 plus 12 plus 4, or 24 plus 4, which is 28. And then we do the top left first, so -7 minus 28 is -35. This is area, which means we 1/2 it at the end. So 35, first of all, we make it positive, and then you can either leave it as 35/2, or you can make it 17.5 or 17.5. I don't care how you write that answer. Just don't forget to change it to be positive, and don't forget to cut it in half for the area.
It doesn't matter. It has to be positive.
Has to be positive. Yep, you just change it.
Can you leave it as 35/2?
Sure. Yeah, I'll take this answer. If it's negative, you're going to lose points. But as long as you make it positive. All right, then you determine if they're collinear. Okay, so we do the same start. 0, -5, 2, 1, 4, 7. Fill the third column with ones and duplicate 0, 2, 4, -5, 1, 7. And then top, left, bottom, right first. So I multiply down 0, 1, 1 plus -5, 1, 4 plus 1, 2, 7. So 0 minus 20 plus 14, which is -6. And then you go back the other way. One, 1, 4 plus 0, 1, 7 plus -5, 2, 1. 4 plus 0 minus 10, which is -6. And then it's -6 minus a -6. That becomes +6, and that's 0. If that answer is 0, then it is collinear. If it is anything other than 0, it is not collinear. So these are collinear. If you had an extra, 30 seconds and you wanted to plot those points and look to see if they look like they're collinear, feel free. But that would not be enough information to prove they're collinear. You'd have to give, it literally will say, use the determinant to determine if they are collinear. So you've got to give me the determinant. Then you have Kramer's rule with a 2-variable and Kramer's rule with a 3-variable. So the first thing I'm going to do is rewrite out my equations into matrix form. So -7, 11, -1, 3, -9, 9. Then I'm going to find D, and D is the X's and the Y's. So -7, 3, 11, -9, and I'm going to come back and do that. And then dx, which is take out the X's, put in the constants. -1, 9, leave the Y's. And then dy, leave the X's, and put the constants in the place of the Y's. And then we go and do the determinant each time. So the Jesus fish, -9 times -7 minus 3 times 11, 63 minus 33, which is 30. Same thing for dx, -9 times -1 minus 9 times 11, and I get 9 minus 99, which is -90. Check to make sure dx is divisible by d. These will be whole numbers, so at that point you can check and make sure at least you're on the right track. And then dy, again, last time, 9 times -7 minus 3 times -1, -63 plus 3, which is -60. So this question is going to get divided into points. Like if you get one of those wrong, you're not going to lose the whole thing. You'll just lose a little bit from there. Then it's going to say use d of x, and d of y to solve the system. So I put x is d of x, which is negative 90 over d, or negative 3. And y is negative 60 over 30, which is negative 2. And my answer is negative 3, negative 2. So I gave you like a little table, like to find d, and then d of x, and then d of y. You'll do your work in those spaces, and then underneath it, you'll answer your x, y coordinate. If you had the time, you could plug that back in and check. Make sure the x, y works. Just make sure you're finished with everything else first. Questions on that one? All right, and then the one, and it's going to be worth the most points because it's got the most work, okay? This is your 3-variable 3 equation. So I'm going to first write my matrix for negative 1, 1, negative 5, 2, 2, 3, 10, and 5, negative 2, 6, 1. So D is the x's, the y's, and the z's. 4, 2, 5, negative 1, 2, negative 2, 1, 3, 6. D of x, I take out the x's and I put in the constants. So negative 5, 10, 1, and then negative 1, 2, negative 2, 1, 3, 6. And then dy, leave the x's, replace the y's with the constants. And then dz, leave the x's, leave the y's, replace the x's or the z's with the constants. So go back, 4, 2, 5, negative 1, 2, negative 2. Top left, bottom right diagonals first. So this is 8 times 6, it's 48. Negative 3 times 5, negative 15. And then positive 2, negative 4. So 33 minus 4, 29. And then we go back the other way. It's 12 minus 2, so negative 24, and then negative 12. Negative 14 minus 12, negative 26. And then I would do 29 minus a negative 26. That becomes positive, and I end up with 55. Repeat the whole process for d of x. So negative 5, 10, 1, negative 1, 2, negative 2. Top left, bottom right. Negative 10 times 6, negative 60. Negative 3 times 1 minus 3. 10 times negative 2 minus 20. Negative 83. Go back the other way. 1, 2, 1, plus negative 5, 3, negative 2, plus negative 1, 10, 6. So 2, this would be negative 15 times negative 2 plus 30. Negative 10 times 6, negative 60. 32 minus 60, which is negative 28. And then negative 83 minus a negative 28 becomes positive 55. No, negative 55, sorry. So again, pause, check, make sure that's divisible by d to give you a whole number. It is. So at least you know you're on the right track. All right, d of y, duplicate again the first two columns. Multiply down the diagonals. 4, 10, 6, plus negative 5, 3, 5, plus 1, 2, 1. 40 times 6, 240. Negative 15 times 5, negative 75, 2 times 1, 2. So 240 minus 75, 165 plus 2, 167. And then go back the other way. 1, 10, 5, 4, 3, 1, negative 5, 2, 6. So 50 plus 12 minus 60, 62 minus 60, which is 2. 167 minus 2 is 165. And the last one. Four, 2, 1, plus negative 1, 10, 5, plus negative 5, 2, negative 2. 8 minus 50, this would be negative 10 times negative 2 plus 20. Negative 42 plus 20, negative 22. And then back the other way. Still going, yep. Negative 5 times 2 times 5 plus 4 times 10 times negative 2 plus negative 1 times 2 times 1. Negative 10 times 5, negative 50. 40 times negative 2, negative 80. Negative 2 times 1, negative 2. Negative 130 minus 2, negative 132. And then negative 22 minus a negative 132 is positive 110. So again, you're going to get, like I gave you a chart, like each one of those gets its own box, and then underneath it's going to say find the solution. So x is your d of x, which is negative 55, over d, that's negative 1. Y is your d of y over d, which is 3. And z is your dz over d, which is 2. And then negative 1, 3, 2 is the solution to that system. Questions? So if you find yourself really reliant on like the highlighting in Notability, like think about the fact that you're doing this on a piece of paper. If you want to bring a highlighter for these, you're welcome to, so you can highlight them. I don't have enough to give everybody, so you're going to have to bring your own, but you're welcome to do that. Obviously, with a minor and cofactor, you can't use them the same because when you cross through, you can't uncross. But these, I think, are better that way. Or a colored pencil, and you want to circle your row. I don't care what you do. Just make sure that you're not, the digital tools that we use for homework and stuff, we don't have tomorrow. Questions on those? Yeah.
So the only ones where you write the thing of ones is when it's area questions?
The thing of, no, area and collinear. The ones that you have coordinate points. So those, you only have 2 terms in each row. You have to add in the ones.
For
Collinear and for area. There's 9 questions. Yeah. Okay, so I'm going to go through this. This is the concepts at the end. When we get back to what we just did, I won't work through all of those questions because they're duplicates, not the same numbers, but extra examples if you want them. And then tonight, I would say you have to do that PDF, which the answers are either odd on CalcChat with the link is in the assignment, or even, and I posted the answers there. So everything that's on your quiz, with the exception of the 3x3 inverse, is basically was 7, 5, 7, 6, and 7, 7. That you'll see again, which is this stuff. 7, it's on the module. It says note. It says chapter SPHA 7.5 to 7.8 review notes. It starts with 7, 5, and this was your adding, subtracting, multiplying, and scalar multiple. So remember, the rule is if you're adding and subtracting, you can only add and subtract if they are the same dimensions. So if we are adding or subtracting only exact same dimensions. So if it says add, let's say, for example, A and B here, like A says, before you even go to multiply 8 in on A and 2 in on B, make sure you can do the next step, which you would not be able to in this case. So definitely take the time to look ahead just that little bit, because it might save you a ton of time. Because this is a 2 by 2 and this is a 2 by 3. Remember, it's rows then columns. This would be a 2 by 2. We cannot add A and B together, so this cannot be done. And if it asks why, they are different dimensions, or the dimensions are not the same, anything like that.
So that's all used right now.
Yep. For B, now you're doing A and C, and those are both 2 by 2, so you can do that. So I would do A times A here. I'd get negative 24, 16, 32, 8. And then I'm going to distribute a positive 2 and subtract. If you did a negative 2, you can add. But I'm going to keep it so that it's a positive 2 distributed. That would be 2, 14, negative 6, and 12. And then I'm subtracting. So negative 24 minus 2 is negative 26. 16 minus 14 is 2. 32 minus a negative 6 would become a right? That's a negative 6. Let me make sure. Yeah. Would become a positive 32 plus 6, which would be 38. And then let me erase that so it doesn't get confusing. This was negative. And then 8 minus 12, which is negative 4. So again, I distribute a positive 2, and then I subtracted. If you wanted to distribute a negative 2, you can add. It's up to you. And then C is A times B. So the rule when you multiply is the inner 2 have to match. And then the outer is the dimensions, I should say, are the dimensions of the product. So if I look at C, A, and B, I'm looking at A and B. The inner 2 match, which means it can be done. The outer 2 is my solution. So it's a 2 by 3. So the first one would be row 1, column 1. So I'm going to multiply. Let me erase this stuff off. I'm going to multiply row 1 from A and column 1 from B in its pairs. So I'd get negative 3 times 3 plus 2 times 4. Negative 9 plus 8, which is 1. Negative 1. Sorry, thank you. Negative 3 times 3, and then 2 times 4. Yeah, A and B. And then I'm doing row 1, column 2. So negative 3 times 3, nope, sorry, negative 3 times 1, negative 1, plus 2 times 5. So negative 3 times negative 1, 2 times 5. For which one? Yeah, we're doing row 1, column 2 now. So positive 3 plus 10, which is 13. Then I'm doing row 1, column 3. So row 1, column 3, and I get negative 3 times 0 plus 2 times negative 2. 0 minus 4, which is negative 4. Then you are done with row 1. So if you literally want to cross it out, feel free. Because now I go to row 2. Row 2, column 1. Row 2, column 1 would be 4 times 3 plus 1 times 4. 12 plus 4, which is 16. Row 2, column 2. 4 times negative 1 plus 1 times 5. Negative 4 plus 5, which is 1. And then the last one would be row 2, column 3. row 2, column 3, which is 4 times 0 plus 1 times negative 2. 0 minus 2, which is negative 2. And then you'll just rewrite that nice and neat for me on the little line I provide, negative 1, 13, negative 4, 16, 1, and negative 2. And be careful with your signs. Then you go A times C, right? So A times C, let me erase all this off. And keep in mind that that's what's going to happen on your, like, so this is where I wouldn't want to highlight. I would want to write lightly with my pencil. A times C, which is a 2 by 2. And a 2 by 2, the inner two match, so it can be done. The outer 2 is my result. So my answer is going to be a 2 by 2. Row 1, column 1 would be row 1, column 1. So negative 3 times 1 plus 2 times negative 3. Negative 3 minus 6, which is negative 9. Row 1, column 2. Row 1, column 2, which would be negative 3 times 7 plus 2 times 6. Negative 21 plus 12, which is negative 9. And then you're done with row 1. It would be row 2, column 1, which would be 4 times 1 plus 1 times negative 3, which is 1. And then row 2, column 2, 4 times 7 plus 1 times 6, 28 plus 6, which is 34. On the, like this one? Yeah. So that was like 7, 5, right? Adding, subtracting, multiplying, scalar multiplication, all that stuff. Then 7, 6 was the inverse. This is the one that you had a 2 by 2 and a 3 by 3, but I told you I didn't put the 3 by 3 on the test, okay? So the inverse on a 2 by 2 is the 1 over the determinant. And then remember, we switched the A and the D and we negate the B and the C. So in this example, I would have to do the fish. So negative 2 minus times negative 3 minus a 6 times 5, which is 6 minus 30, negative 24. And then I do 1 over that. So 1 over negative 24. And you take your determinant, or what's in here, not your determinant, but your 2 by 2. You switch the A and D, so the negative 2 and the 3 and the negative 3 switch positions. And you change the sign on the other two, so negative 5 and negative 6. And then we distribute in. So I'd get positive 2 over 24, positive 5 over 24, positive 6 over 24, and positive 3 over 24. And then you have to simplify every single one of those. So 1/12, 5/24 doesn't simplify, 6/24, 1/4, 3/24, 1/8. So if it can be simplified, it needs to be, and you want to be careful with your signs. Questions on those? So again, 3 by 3, not on, inverse of the 3 by 3, not on the test. Okay. So then this, you want this, what this is. Don't worry about that one. The minors and the cofactors, and honestly, just because I was worried about time, you're only doing one row. So you're only doing row 1. So you're going to literally get a minor 1, 1, minor 1, 2, minor 1, 3, and then it'll be cofactor 1, 1, cofactor 1, 2, cofactor 1, 3. That's what it's going to look like, okay? So if I'm doing 1, 1, I cross through row 1, column 1, and I'm going to find the determinant of what's left. So 4, negative 1, 2, and 5. 5 times 4 minus 2 times negative 1, 20, minus a negative 2 becomes plus 2, and that's 22. And this is where you're gonna like, you know, nice and lightly draw on your quiz because you don't want to write so hard that you have to erase back like hard and then lose the number. So then I go to row 1, column 2, and I would do row 1, column through. Those are the ones you'd cross through, and you'd end up with 0, -1, 5, and 5. So it's 5 times 0 minus 5 times -1, and you'd get 0 plus 5, which is 5. And then row 1, column 3, and you have 0, 4, 5, 2. And then it's 2 times 0 minus 5 times 4. 0 minus 20, which is -20. So in your matrix, those would be the ones in that top row. This one, this one, this one. So you're only giving me those 3. And then when you do the cofactors, remember you change only the middle sign, right? Because we would change here, here, God bless you, here, and here, which means you only have to change the 5. So the cofactor of 1, 1 stays 22, 5 would become -5, and then 1, 3 would be -20.
We're not gonna have a cofactor and minor with 2 by 2. Like it will be.
There's one on the review. That's where you just cross out, and it would just move.
But there's gonna be one on the test.
Yeah, I think that there's one. No, it's only 3 by 3. Yep.
You can only find the first row.
It's only going to tell you to find the first row. Yep. But minors and cofactors. So you just have to change the sign in the middle one. Yep. And then comes like all of the 7/8 stuff, which like I said before, we're not going to work through it all over again. Just remember what to do. So the area is your x, y, your x, y, your x, y. Fill with ones. Find the determinant. Make it positive. And then multiply it by 1/2. So that's what we did on the warm-up.
Don't we add the x, y, and this? Like,
Yeah, when you duplicate it, yeah. Those bars just mean find the determinant of this.
how did you put the x, y, and that x, y, and
You would. This means find the determinant. So I'm not going all the way through the steps, but that means find the determinant of that 3 by 3. So then you would duplicate the first 2 columns and do your dashes.
And then at the end, you do the 1/2 to the
Yep, and make it positive. And then collinear, you'd set up the same thing. Your x, y, your x, y, your x, y. You put your column of ones. You're going to find the determinant of this. If it equals 0, it's yes. If it doesn't equal 0, it's no. And then you're going to get 1 Kramer's 2 variable and 1 Kramer's 3 variable like we just did on the warm-up.
Are we gonna get the one where it's basically area, but they would give us 4 points?
No. So I do have, like, if you want to work this out, you can. I have the solutions. I'll post them at the end of the day. Like, it worked out. Same for this one. But they are also on your PDF review. So on your PDF review, which is on the assignment, here's your adding, subtracting, right? Like adding, subtracting, multiplying is here. Multiplying is here. Inverse of your 2 by 2. And then it goes into 7, 7. This determinant, this is what I was talking about before. It's not going to say... These two, you're not going to get straight up questions that say, find the determinant of the 2 by 2 or the 3 by 3. Instead, it's built in to Kramer's rule and all that other stuff. So there's no specific question that just says, find the determinant. Okay? Those are good for practice, but it's not on there. And then your minor, this is, practice the minor of the, good morning. Give me just a second, okay? The minors and the cofactors in the top of a 2 by 2 and the 3 by 3. And then in the bottom, this is all the 7, 8 stuff. So you've got your area, you've got your collinear, you've got your Kramer's rule. Last one on the last page, there's 2 examples of each of those. So you need to do as much of this as you need to do in order to make sure that you're ready to go for tomorrow. But we basically just did everything within today.